From the today onwards, we will start a new unit. So the new unit name is Modern Symmetric Cipher. And you can see Modern Block Cipher. So what is Modern Block Cipher? So you already know about the block cipher, in which we have to divide our plain text into the multiple blocks, right? So when the plain text is divided into the multiple blocks, like it is a block 1, it is a block 2. So each block will contain some bits, like n bits, suppose. And if your plain text is divided into multiple blocks, and in that case, I am supposing that my number of blocks are m. So it is a mth block, which is again n bit. So that is called the block cipher. So it is a plain text block, and you have to do the encryption one by one with using encryption algorithm with a key. And when the encryption is performed, it will give you ciphertext block. The ciphertext block can contain n bits. Right? So the modern, what is the term of modern? Modern over there. So this is a case of the block cipher, modern block cipher. The definition: modern block cipher is a symmetric block cipher that encrypts n bit block, that is that one, plain text, and decrypt of the ciphertext. So it is a symmetric key block cipher decrypts n bit block of plain text and decrypts n bit block of ciphertext. Okay, very simple. So it is a case of symmetric key, means you have to use the same key for the encryption and the decryption, and also encryption and decryption algorithm will be inverse of each other. So for that way, for that purpose, I will mention some another points also. Like in the modern block cipher, encryption and decryption algorithm must be inverse of each other. And will use k-bit key. So your key should not be always n bit, it should be k-bit. So कैसे निकालेंगे वो अभी हम बताएंगे आगे. So for the diagram, जो कि आपको एग्जाम में बनाना है, अगर क्वेश्चन आता है व्हाट इज मॉडर्न ब्लॉक साइफर, so that is your n bit plain text. So this n bit plain text, over this n bit plain text, encryption algorithm will be applied. After the encryption algorithm, n bit ciphertext will be generated. For the decryption point of view, we have to use n bit ciphertext. because we are doing decryption, so it will be associated with decryption algorithm with a k-bit of key. So after the decryption, your n-bit plain text will be generated. So it is a decipherment process and it is encipherment process. Because we are talking about the symmetric key cryptography, encryption and decryption will use the same key, k-bit key. So that is the basic fundamental regarding the modern block cipher. Now what is the concept in order to introduce of this modern block cipher? Here n-bit plain text, what is the meaning of n-bit plain text? N-bit plain text means the plain text having n bits, right? So there is a one mandatory condition that your plain text must be n bit. तो इसका मीनिंग क्या है? One second. क्या मुझे पता है? So here n bit plain text means if the generated message sent by the sender, because there are two entities involved now, Alice and Bob. Alice will be act as a sender and Bob will be act as a receiver. So if the generated message by the Alice, n-bit plain text means if the generated message by Alice has fewer than n bits, means it is less than n bits. The generated message, the bits containing in the message, generated message by the Alice is less than n bit, then we have to perform the padding. Then padding should be performed in order to make it n bit plain text. To make it n bit plain text. Now the second case is if the message generated by the Alice is greater than n bit plain text. यही सेम केस होगा, पर यहाँ पे क्या है कि जो मेरी बिट्स हैं इनसाइड द मैसेज इज ग्रेटर देन n बिट्स प्लेन टेक्स्ट. इट इज अलाउड अलाउएबल प्लेन टेक्स्ट बिट कि मेरा जो प्लेन टेक्स्ट है वो इंक्रिप्शन के लिए n बिट होना ही चाहिए. दैट इज द मैंडेटरी कंडीशन. सो यहाँ पे वॉलेटिंग कंडीशन ये आ रहा है फर्स्ट केस में. दिस इज द केस फर्स्ट दैट the bits containing in the message generated by the Alice having fewer bits as compared to the allowed bits, that is the n bit plain text bits. So in that case padding must be performed. And in the vice versa case, when the message generated by the Alice has higher than bit, then it should be, then message should be divided into n bit block, n bits multiple block. And after dividing into the n bit multiple blocks, it may be possible that the first block will contain n bits, okay, the second block will contain n bits, okay, but it may be possible, there may be a condition occur that the last bit will not contain the n bits. It may contain less than n bits, means the first case. If that case occur, then bit padding must be added to the last block. Okay, and padding must be added to the last block if necessary. So what are the common values of this n? So in general terms, what are the cryptographic algorithms of the modern symmetric cipher? That is DS, AES. तो DS AES मैं ट्राई करूंगी कि आपके मिड सेम में ना दूं क्योंकि ऑलरेडी सिलेबस बहुत ज्यादा है मिड सेम का, तो अभी वो मैं कंफर्म करती हूँ नेक्स्ट वीक में. सो डीएस के लिए जैसे कि जो मेरा प्लेन टेक्स्ट है वो 64, एएस के लिए 128 होना चाहिए. सो द जनरल वैल्यू ऑफ एन कैन बी 64, 128, 256, 512 bits. Means your plain text generated by the Alice must contain the bits of 64 or 128 or 256 or 512. If it is not, then you have to perform the padding case by case. If it is fewer, then padding must be added. If it is not, then you have to divide your block into the n-bit word, and if necessary, you have to perform the padding at the last block. So what is one of the numerical example? The question is, that we have 100 characters. The plain text contains 100 characters, and for the encoding, 8-bit ASCII is used. And the encryption algorithm of the block cipher accepts block of 64 bits. Now the question is, how many padding bits must be added to the message? Question is, how many padding bits must be added to a message? So question can be arrived in the examiner manner that it is necessary to do the padding, or how many blocks it can be generated in order to do the cipherment process. So whatever the question is, you have to do analysis that what is asking, and you have to perform the computation. So in the message there are 100 characters and you have to use 8-bit ASCII is used for the encoding. तो 100 कैरेक्टर्स है मेरे प्लेन टेक्स्ट में, तो हर एक कैरेक्टर के लिए मुझे 8-bit ASCII वैल्यू चाहिए. सो कितना हो गया मेरे टोटल बिट्स? That is 800 bits. So now we have 800 bits and my block cipher size is 64. So now tell me which case it should belong, the first case or the second case? Obviously second case, in which my message size bits, the bits in the message size is greater than the block cipher bits, that is the 64, right? If the second case will be applied, then you have to perform the division of your message into the multiple blocks, and each block should contain 64 bits, and you have to check that the last block will need padding or not. So first you have to calculate the number of padding bits. So what is the formula? The formula is very direct. That is your message size plus necessitated padding bits. So when you add this message with the padding bits, the whole size must be completely divided by this 64 bits, means the remainder should be 0, right? So that is one of the formula you have to use in the modern block cipher in order to calculate the number of adding bits as well as the number of generated blocks for the encipherment process. So in this example, my message size is 800 bits. So to do more simplification, I can write this formula this way, or I can write this formula this way also. So because we require padding bits, so we have to check if there is a remainder, there is a completely 0 over there, so we can say there is no padding bits we will require. Otherwise, after the calculation, it will give you some value. So we have to check there is a value or not. So what is the message size? That is 800 and mod 64. Now compute it. So it is 32 mod 64. Because this is a minus value, you have to convert it into the positive one. So it will be automatically give you 32. The number of padding bits must be 32. Means you have to append 32 zeros message. It means zeros, 32 zeros have to be added to the last block. You can say appended to the last block of the message. Now we computed the number of padding bits. And you know that your message size, the bits containing the message size is high as per the allowed block cipherment block size. That is the 64 bits, means the second case. In the second case, you have to divide your message into the multiple blocks of 64 bits. So how many blocks can be generated? The second question is, how many blocks can be generated? So there is a formula that the number of blocks will be computed by message size plus your padding bit divided by the block size bits. So what is your message size? 800. What is your padding bit? That is 32. And what is your block size bits? That is 32. Sorry, 64. Now compute it. It is 832 divided by 64 and 13. So mean 13 blocks will be generated in order to do the cipherment process. And in the 13th block, 32 zeros will be appended. Okay? So 13 64-bit plain text block will be generated. And the padding will be done over the last block, over the 13th block. Now the third question is, how many times the encryption and decryption algorithm will run? How many times encryption and decryption algorithm will run? So sometimes the student give the answer of 1 कि एक ही बार लगेगा, पर 1 is not the correct answer. How many times your encryption algorithm will run? You have generated 13 64-bit plaintext block. Just see the upper diagram in order to analysis it. So in the upper diagram, it says that your massive size is divided into the multiple n-bit block. So in the question, there are 13, like starting from 1 to 13 block, and each block will contain 64 bits. So how many times you have to run the encryption algorithm? 13 times. And how many times you have to run the decryption algorithm in order to generate the plain text? 13 times. So the answer is 13. Now I'm giving you one question. Suppose the message is having 100 characters, sorry, 120 characters and 8-bit ASCII value is used for encoding. So how many number of blocks will be required and how many padding bits will require if block size is 128 bits. Now compute it and tell me the answer. So now I'm going to tell some facts about the substitution and transposition cipher. So in the substitution one, what are the key facts related to the security? In the substitution cipher, suppose this is our bit So each bit will be replaced by either 0 or either 1, right? It will also replaced by either 0 or either 1. So it will be the case for all of the bits. It will be replaced by either 0 or either 1. Substitution cipher. So 1 bit or 0 bit is replaced by either 0 or 1. So we can say the plain text can have different number of zeros and ones, and ciphertext can have different number of zeros and ones with respect to the plain text. ठीक है, so यहाँ पे कितने हैं मेरे ones, zero कितने हैं, zero है मेरे 3 और 1 कितने हैं, 3 4 5 मेरे 1 है. तो इन द साइफरमेंट प्रोसेस जब मैंने इसमें सब्स्टिट्यूशन परफॉर्म किया, फर्स्ट बिट को सपोज मैंने रिप्लेस किया 1 से, सेकंड बिट को 1 से, थर्ड बिट को मैंने 0 से किया, इसको फिर मैंने 0 से किया, इसको मैंने 0 से दोबारा कर दिया, देन इसको मैंने फिर से 0 से कर दिया, देन 1 and 1. So in that case, how many number of zeros are there? The number of zeros are 4 and the number of ones are 4. So it may be possible that in the substitution cipher, it may be possible, क्या possible होता ही है कि plain text और cipher text में मेरे different number of zeros and ones होंगे. So we can maintain a relationship of zeros and ones, means the number of zeros and ones between the plain text and the cipher text. But what about the transposition cipher? In the transposition, the same example 1 0 1 1 0 and 1 0 1. Transposition cipher basically do the permutation of the bits with the size of, with the indexing of the values like 1 2 3 4 5 6 7 8. So the 1th value will be replaced by the 8-bit value, replaced by the 7-bit position value and so on. ठीक है, तो ये ऐसे रिप्लेस हो गया, ये इसके साथ रिप्लेस हो गया, ये इसके साथ रिप्लेस हो गया and so on. So we can say the number of bits, means the number of zeros and ones in the plain text will be equal to the number of zeros and ones in the ciphertext. So plain text will contain same number of ones and zeros like in ciphertext. So in order to do the attack, what much time we will need in order to break the cipher? So regarding this, one of the question is, suppose we have a block cipher and n equal to 64, and it is given that the ciphertext contains 10 number of ones, means 10 ones are there in the ciphertext. The question is, how many hit and trial method you can say how many hit and trial tests made by Eve. Eve is attacker. Made by Eve to recover the plain text from the ciphertext. So when there are two cases, when we have used substitution cipher, so from the case of substitution cipher, we know there are different number of ones and zeros in the ciphertext and the plain text. So in the question, it is given the ciphertext contains 10 ones. So it does not relate that my plain text is always contain 10 ones because it is given in the ciphertext that it contains 10 ones. So in that way, there is no relationship can be established between the plain text and the ciphertext. So how many combinations we have to check? All the possible combinations, that is 2 to the power 64. And it will take a lot of time. Now the second condition, that is a transposition cipher. So when we use transposition cipher, in that case, we know that the number of ones and zeros in the plain text will be same as the number of ones and zeros in the ciphertext. In that case, how many hit and 12 we can run? The 64 factorial, because we are doing the position wise permutation, in which 10 ones are commons, and how much is remaining? That is 54. So it will take less time as compared to the breaking of cipher when we use substitution cipher. So we have to check only 64 factorial, 10 factorial into 54 factorial plain text combinations out of 2 to the power 64. So this is some realistic fact about the substitution cipher and the transposition cipher. So we can say the substitution cipher is more secure as compared to the transposition cipher. Now related to this fact, there are two another topics, that is full size key transposition block cipher and full size key substitution block cipher. ये हम क्यों पढ़ रहे हैं? क्योंकि स्टार्टिंग में मैंने बताया कि n बिट का प्लेन टेक्स्ट होगा, n बिट का साइफर टेक्स्ट होगा और मेरी जो की होगी वो k बिट की होगी. बट व्हाट शुड बी द वैल्यू ऑफ दिस k बिट? ये हम कहां से निकालेंगे? यहाँ से. सो फुल साइज की ट्रांसपोजिशन साइफर. Transposition block cipher. So as you know, in the transposition block cipher, we have to change only the position of the bits without changing their value. Means we have to transpose the bits inside the block. So suppose we have n bit plain text. So in order to do the transposition, how many permutation we have to perform? N factorial. So if we perform the n factorial permutation in order to do the cipherment process for the transposition block cipher, then what should be my key size? Because transposition cipher can be of two types, keyless or keyed. And we are in this topic, we are talking about the keyed cipher, means transposition keyed cipher. तभी हमें यहाँ लिखना है ना full size key transposition cipher. So what is the key size? So let's take one example in order to find out what should be the key size. Suppose n equal to 3. So n equal to 3 means in the plain text we have 3 bits. So one first bit, second bit position, and the third bit. So it is a 3-bit plain text. So after the permutation, we have to only changing the position of my plain text. So it may be possible that it will be 2, 1, 3, 1, 2, 3, what is. So मैं ऐसे लिख देती हूँ 1, 2, 3. आप कुछ भी लिख सकते हो, 3 to 1, 2, 3, 1, जो भी आपका मन करे आप लिख सकते हो. So when the encryption process is going on, what should be my possible outcomes? एक्चुअली इसका यहाँ पे कहने का मतलब ये है कि अगर मैं प्लेन टेक्स्ट में 1, 2, 3 बिट्स ले रही हूँ, 3 बिट का मेरा प्लेन टेक्स्ट है, सो आफ्टर द एन्क्रिप्शन मेरे को 3 बिट ही मिलेंगे. ठीक है, और वो 3 बिट का जो सीक्वेंस होगा वो मेरा चेंज हो जाएगा. सो व्हाट विल बी द पॉसिबल सीक्वेंस? like 1 2 3, 1 3 2, 2 1 3, 2 3 1, 3 1 2, and 3 2 1. So there are 6 possibilities of the permutations. That's why I'm taking n factorial permutation. So n factorial permutation means you have to perform 3 factorial permutation outcome can be generated. 3 factorial means 6 elements. What are that 6 elements? These are the 6 elements. 1, 2, 3, 4, 5, 6. So in order to generate this 3 factorial permutation means 6 elements, the outcome should be the 6 elements. What should be the key size? तो अगर थोड़ा याद हो ट्रांसपोजिशन साइकिल में जो मेरी बिट पोजीशन होती थी वही मेरी की का काम करती थी, डेट इज 1 2 3. तो मैं क्या करती थी कि की लेती थी 2 1 3 और जिसको मैं बोलती थी कि फर्स्ट मेरा सेकंड से रिप्लेस हो गया है, सेकंड मेरा फर्स्ट से रिप्लेस हो गया और 3 मेरा 3 से ही रहा है. ठीक, तो मेरे को चाहिए 3 बिट की. So what should be the key size? How can we calculate from the generated elements? So log base 2 and 3 factorial. So what should be the outcome? Log 6 and the answer is 3. So in that case, full size key transposition cipher, my key will be 3 bit, means n bit. Key is 3 bit. So what is my key size? The key size will be log base 2 n factorial. Then what about the full size key substitution cipher, substitution block cipher? So in the substitution cipher, we do not transport the bits. We have to change the values of the bits. So we have to, in the full size key substitution block cipher, we can perform the permutation by the encoding and decoding of the bits. Can perform permutation by using encoding and decoding. So in the decoding, what we have to do, there is n bit plain text. We have to convert it n bit plain text into the 2 to the power n possible values. And in the decoding कहाँ गया? Sorry, encoding. We have to do the reverse process. So for example, for the better clarity, I will illustrate one example that what I am trying to say and how we will find the size of the key in terms of the substitution cipher, substitution block cipher. So suppose the same value I am taking, that is n equal to 3. So for the decoding, as I say, it will take n bit, means 3 bit, and it will convert it into 2 to the power n. So 2 to the power 3 means 8. So 0 to 7. 7 bits are there. 0 to 7 bits are there, means total 8 bits. So we have to use 3 into 8 decoder. So this 3 into 8 decoder will give you 8 objects. क्योंकि ये मेरा input होता है, ये मेरा output होता है decoder में. So it will give you 8 objects. And after this 8 object permutation, you have to perform the encoding. So encoding is a reverse process, means you have to convert it 8 into 3 encoder, and 3-bit values will be generated as the output. So because we have used 3 bits and equal to 3, so this is my first bit, this is my second one, this is my third one. So decoder we have to use in the first step. So 3 into 8 decoder we will use. So this decoder will give you 8 objects from 0 to 7. So 1, 2, 3, 4, 5, 6, 7, 8. And here it will provide you 8 object permutation. After the permutation, you have to perform the encoding. 1, 2, 3, 4, 5, 6, 7, 8. So for the encoding, you have to go the reverse process, means 8 into 3 encoder. And again, it will give you 3 bits. So what is our 8 object permutation in this case? 8 object permutation will be 1, 2, 3, 4, 5, 6, 7, 8. This is the first permutation. Second permutation will be 1, 2, 3, 4, 5, 6, 8, 7. 1, 2, 3, 4, 5, 8, 6, 7, like so on. So how many permutation we have used? Like 8 factorial. We have generated 8 factorial permutation. The set of permutation is 2 to the power n factorial. क्योंकि मेरा n क्या था? 3 था ना, और यहाँ पे मैं क्या कर रही हूँ? 8 factorial कर रही हूँ. So 2 to the power 3 means 2 to the power n factorial. 8 factorial. And how many value will it generate? 40,320. So what will be my key size? Key size will be log, and this value, that is 8 factorial, and in the generalized way we can write it log 2 to the power n factorial. So for the 8 object permutation, we will use key size of log 2 to the power n factorial. And what should be the number of bits? Let's calculate it. Log 8 factorial, it will be 60. So this is one of the proof that can clear your impact over the these two facts, like the substitution cipher and the transposition cipher. There are so many combinations you have to check because the key size domain is very, very large. But in this case, the key size domain is less. So that is all about the today's lecture. In the tomorrow onwards, I will continue the modern block cipher. What are the components? क्योंकि components बहुत ज़्यादा mandatory है in order to learn the DS and AES ciphers. और complex भी हैं थोड़ा understand करने में. So any doubts regarding the today's session? If you have, you can mention in the chat. Otherwise, you can leave the meeting.